Hello there guys, and welcome back to another epic inexorable maths video. In this video we're looking at how we're going to use the reverse chain rule to integrate tan x. So we already know the integral of sine and cos. I have another video on that which I will leave in the description of this one. You might say, okay, what about the third fellow? What about tan x? What's the integral of tan x? Is it maybe something to do with sine and cos? Well, not really, a little bit, but it's actually something a little bit more complicated. We need to use the reverse chain rule in order to do this. So I'll also leave the reverse chain rule link in the description below. We need to understand the reverse chain rule. So what we're going to do in order to figure out what this integral is we're going to use the trigonometric identity that tan x is actually just the same thing. If I call both of these integrals I, it doesn't matter what I is, I'm just to represent they are the same integral. Tan x is just sine x over cos x. So if we work out what this integral is, we are getting the equivalent integral to tan x. They're the same thing. So we're going to write tan x as sine x over cos x. So hold on, okay, but still how do we do it from here? Aha, this is where the reverse chain rule things comes through. Remember, if you have an integral that is in the form something on the denominator and multiple of the derivative of that thing on the numerator, then it's a reverse chain rule. So we're going to consider differentiating the natural log of cos x, because cos x is on the denominator. So you always consider the natural log of the thing on the denominator. The reason for this is because when you differentiate a natural log, where does the natural log come from? If you differentiate a natural log, you always end up with the same thing. You always end up with this format. It's always whatever's in the brackets, the derivative of that, so the derivative of cos is minus sine, divided by the thing in the brackets, which is cos x. Hold on a second, the derivative of the natural log of cos x is just negative sine x over cos x, which is negative tan. We're trying to integrate sine x over cos x. If we differentiate the natural log of cos x, we just get negative that. So that means that this must integrate to minus the natural log of cos x. It must be equal, I must be equal to negative the natural log of cos x. Okay, so if we say, hold on a second, why is that? Elaborate. Well, if we were to differentiate this, the negative natural log of cos x, we would get minus this, because this is just the derivative of natural log cos. We're just timesing this by minus 1. Minus sine x over cos x is just sine x over cos x, which is tan x. So if we differentiate that, it does indeed give us tan x. Amazing. Hold on a second though. We can maybe write this in a slightly nicer way, because minus the natural log of something is just the same thing as minus 1 times the natural log of this cos x, right? It's just negative something is just minus 1 times that thing. So what we can do is we can consider minus 1, and we can bring minus 1 into the power inside of that logarithm. You can use logarithm rules for this, and you end up getting the natural log of cos x, and it's all in brackets raised to the power of minus 1. So the minus 1, we're going to float him up to the top right there as a power. You can do that because that's a logarithm rule. Now you might say, hold on a second, what's going on? This is a bit gross. Actually, it's not. When you raise cos, this is not inverse cos. This is not cos to the minus 1x. It's not r cos. It's actually just cos, literally cos to the minus 1, which is over cos. 1 divided by cos x is sec x. So actually this is the natural log of sec x, if my tablet works. Sec x. Like that. And that's the answer. Plus c, of course. So that means that the integral of tan x dx is the natural log of sec x plus c. You can verify this by differentiation using the chain rule, because this is the reverse chain rule, so you can use the chain rule to verify this. This is true. The integral of tan x is just the natural log of sec x plus must see. If you enjoyed the video, thank you so much for watching. I highly appreciate it. Share with your friends and family, and I'll see you in the next video. Cheers.